then I don't need to stick here. Yeah, my great pleasure to kick off today on this stage. Very nice and appreciate you be here this early morning. I know last night there are like galas and parties. Yeah, really appreciate it. Yeah, so today I'm taking you to a journey of my research, which is in industrial metaverse, and it's in this general context of Industry 5.0, so like this human-centric, resilient, and sustainable industrial future. And I will specifically focus on digital twin and extra technology as the theme of the event. Yeah. So first, a few words about myself. So I'm based in Finland. I'm a postdoc researcher at Aalto University in Helsinki area. I'm also like a research collaborator with University of Cambridge on Cyber-Human Lab on human augmentation technologies. And formally, I also work as a AI and operations consultant at PwC Finland, working also in the scientific advisory board for Metaverse Institute, focused on responsible development of Metaverse. Yeah, and also I try to get involved in many standardization initiatives and also Industry 5.0 initiatives in Europe. Yeah, and my keyword of my research focus area is Industry 5.0, Metaverse, specifically for industry applications, digital twin, XR, and applied AI. Yeah, I did my doctoral study. I defended my doctoral study last year, so that was my topic. So this talk is also a wrap-up of that and also my recent research activities. Oh, okay, let's get started. So this is outline of my today's talk. So first, I will give you a introduction of what is Industry 5.0 and Metaverse. Then we'll go deep dive into the core technologies. Then finally, we look into when we actually entering Metaverse, what risks and challenges, and how do we address them with some architecture solutions, and also considering the ethical and legal implications. Yeah, let's get started. First, a historical lesson. So, you know, I talk with many people here at the conference. For some people, Industry 5.0 is still a new concept because, as you heard, the previous industry revolution, which are mostly technology-driven, but Industry 5.0 is more like coming from those soft values. So it has these characteristics. So first, the human-centric approach. So focus on really, like, you know, kind of what make the job more attractive in the future, like manufacturing, because, for example, younger generation will not working like in factories is not a sexy job anymore. So how to really like emphasize the human creativity's well-being, being its physical well-being and mental well-being, and really maximize the human values. And then the second feature is this technology synergy. So different like emergent technologies, how to really combine them and find the synergistic interplay of them for different applications. And then also the focus of the sustainability and also resilient, especially considering the supply chain disruption in the past years. Then also it comes to personalization and customization. So instead of mass production, kind of the future production line is really kind of customized and adaptive to individual need and also to support this personalization preference. Last but not least is this collaborative ecosystem. So meaning like along the supply chain, different stakeholders, being like policymakers, to like business, to like researchers. So it is this ecosystem and platform approach. Yeah, then go to Metaverse. So my view is that Metaverse really have this potential to bring, to have this capability to merge the physical and the virtual world and bring a enriched experience for human workers. So therefore, forging the Industry 5.0 vision. So what is Metaverse? There are all kinds of definitions. Someone says next evolution of internet, except it's less flat, not in 2D screen, but like in the 3D immersive space. some definitions focus on this user-centric approach, so connect the physical world and the digital world. And also, some aspects emphasizes interoperability aspect, immersiveness, and also the synchronization features. And then there are also definition which is very broad, like just say, okay, metaverse is a convergence of different technologies. That might be too broad, but I think it captures also some essence of it. So this is another view to see it, metaverse, where we are now, or this technological convergence. So where we are now, there are different technologies, and of course, they are connected with users, but also they are siloed. Where we are heading the future is that like we share the assets, the digital identities across different platforms, different apps, different systems, and it's bring more like interoperability and flexibility in terms of the user experience. Yeah, this is another view. Still demystify what is metaverse and what is industrial metaverse especially. So basically, I have these three categories of metaverse. First is consumer metaverse. I think a lot of you working in this field as well. So this is also maybe people more familiar with the metaverse version, vision of metaverse. So it's focused on social media, entertainment, gaming, and shopping experience. So bring the virtual experience directly to the end consumers. Then we have the enterprise metaverse. So this focus on marketing, employee engagement, meetings, and events. And then come to finally the industrial metaverse, which is my focus. So this really focus on bringing the industrial values and focus on like industries such as construction, healthcare, manufacturing, supply chain, these areas. So imagine like instead of like checking the physical factory, you can work in the virtual version and experience it, do run some experiments, and also do the real-time kind of operations. And still setting up the motivations. So why industrial metaverse and what's the connections with like what I said before about Industrial 5.0. So since I work as consultancy and there was ESG, at least in Europe or in Finland, is like a big topic. So this environmental, societal, and governance goals. So on the environmental side, of course, there are computational powers consumed by metaverse. But on the other hand, this virtual experience and can also save energies and waste reduction, especially in industrial domain. And also it promotes more efficient resource utilization and also reduce the physical travels and carbon emissions. Here I have an example of Siemens using their digital twin approach to help Maserati to reduce the time to market by 30%. So this is like a public case. And then secondly, on the societal side, so virtual trainings, VR trainings, and also when you are like free, like newbies in some new line of work, for example, assembly, there are some on-site like AR augmentations. And so this can improve like workplace safeties and also considering like using AR, VR to consider different users' needs, have this adaptive interface. It can also consider and incorporate accessibility and inclusion aspect and eventually improve workers' physical and mental well-being. So here there is a case about Ford. They use the virtual training for their assembly lines to significantly reduce injury rate. Then finally, on the governance side, I guess many of you have heard this EU, we have the digital product passport. So that's one step. So kind of the I think it's gradually already applied in textile and battery, electric car battery industry. So every new product needs to have these digital passports that track the life cycles. So Metaverse also enable this aspect from like digital twin like capabilities. So increase the transparency and accountability of any product, and also increase the privacies and securities. Here also I have example of ABM. They use digital twins or like blockchain technologies to trace consumer product. Yeah, so And then also a bit motivation from like policy side. So Industry 5.0 is currently a big focus, at least in EU. There are a lot of calls in these areas from Horizon Europe in terms of research and innovation. And also in Finland, to promote welcome to our booth in the exhibition area. So we have this now Metaverse Finland ecosystem. So it's part of our national strategy as well. So a lot of emphasis and exciting activity going on there. So motivations aside, now let's dive into more on the technology and some of my research insights. So one key technology of industrial metaverse is digital twins. What is digital twins? So basically, digital twins is the digital replica of the physical counterpart and have the real-time data linkage between the physical world and the virtual world. Why digital twins? Here I listed a few like use cases along the like in industrial applications. So as you say, from early like rapid prototyping, testing to production planning to quality control. So really during the operations to like end of life like documentation, communication, training, and simulations. So different use cases. So basically, digital twins provide the real-time data bridge between the physical world and digital space. So kind of bring the data backbone to the whole system or the metaverse. Then come to XR. I think considering audience, no more word about it, but basically VR, AR, or MR. The difference, like here, I also list the applications in industry. So very similar to digital twins, but the difference is that digital twins is provide the data backbone, so behind the stage. But then XR is really provide this immersive user experience for shop floor workers, for managers in factories to really interact and experience with the digital system, with the data to view and also interview with it. Here I have a use case I developed back then was 2021, so it was still using the Microsoft HoloLens one. So this was about overhead like industrial crane control. So here basically in the warehouse, the users can, instead of the traditional way, which is having a quite heavy like controller, manual controller with joysticks to control the hook movement. So here you just need to have the goggles on and it's hand-free. And you can see on the top left side, there's this virtual dashboard in front of you. So of course, the background is actually transparent, so it doesn't block your vision, so you can see the real-time control. But also, the way to control the crane movement is that you can drag and drop the virtual balls in the space, and then crane will run to the directions. So on the back end, then we have different models. So the interaction model, which is control the crane hook movement. Then we have visualization to get the visualize the real-time data from the crane. Then the communication model is using the crane's GraphQL API connect with the OPC UI server of the crane. And then we have the registration model, which is synchronize the real world and physical world. Was using Euphoria image target at the time. So this is a use case, early explorations. Now we're looking into a bigger picture. So that was a more singular use case of combined digital twins and XR. And now we're looking into more on the broader pictures of metaverse. So looking at what challenges. So first, some risks. So this is a survey run by PwC on top risks and barriers business leaders worry about. So of course, the first few is regarding cybersecurity and privacy risks, because boundaries of the virtual world and physical world is emerged, and also this more invasive like interface kind of collect your data like anytime. So that's raised a concern in this field. Then also the technology constraints. Because the hardware is still developing, evolving. I think in this event, I saw a lot of exciting activity going on, really looking forward to what's next year, like what's the new hardwares. But of course now, still like long-term use, especially in industry environments, sometimes very hot, and you have these goggles on. So not always nice for long-term use. And also all the software ecosystem, especially for industrial applications, are not there yet. So still the technology constraints is one of the biggest concern. Then also comes the regulatory uncertainty. I think now also in this event, you hear a lot about EU's activities here on virtual world and new regulations. But still now, I will talk a bit later in the slides, still there is no specific legal aspect, and also different territories, it might have different legislation regarding this. So for business to enter the global market, still have the uncertainty. Then also the intellectual property or IP concerns. So here is regarding when like factories or like manufacturing providers, if they put their virtual assets in the digital space, of course, it's improve the data interoperability, but also the IP concerns here is still uncertain. So risk ahead. Here I would present also a recent research of mine published last year on industrial metaverse architecture. So it's a very long paper. If you want to see details, you can go deep into it. So basically, here is the outline. So I have the physical space on the left side. So here are the tangible entities. So machines, materials, personas working in the factories and monitoring the process, of course, and the whole environment. Then underline that there's the digital, more like infrastructure side from sensors, actuators, network, and also support systems. And on the right side, you can see the metaverse space. So here is also this modular architecture. So on top side, you can see the data flow. So basically the digital twins I talked about earlier. So have the coupling for data exchange, then data storage to maintain the data integrities. And then underline that is the knowledge synchronization. So here I want to emphasize, if you are not familiar with the concept like semantic models, so basically like data can come from different components in the system, but the problem is that they can be talking different languages. So semantic model is like provide these common dictionaries to look up for different data from different components in the system, so they can understand and interpret with each other. So there's these semantic link models. And then on the right side, you can see the extra interface. So basically, I have different models here. So communication, visualization, control, and spatial registration for the synchronization of the physical world and the digital world, but also the customization. So this is a special like module, especially for this human-centric need. So basically, it means the extra interface should and ideally adapt to different machines, different material flow and environment, and also especially the personal need. So be it expertise levels, its preference, or it have some workability limitations. So the extra interface can utilize knowledge base from the semantic link to get from the physical world this knowledge input and adapt the interface accordingly. And in the middle, we have different supporting functions. So identifier and security is more addresses privacy and security issues I talked about earlier. Then simulation models is more like a specific one kind of use cases, especially for simulation need in manufacturing and production environment. And then we have computation, analytics, and AI, especially AI, I think we talked about in the events, like how to combine with X and AI. There are a lot of potentials, especially like in generating the scene and also the Gaussian splatting, like quickly like have scanning of the factory floor and have the virtual versions of it. And also like AI personas, like large language model agents in the factory floor. So we have currently research going on in that field to have a persona to give a like factory tool and have the knowledge base to have you can have real-time interaction with it. So that's in a nutshell. And I also, in the paper, in the research project, I applied this proposed architecture to use case. So this is implant material flow tracking. It's happening in our university's industrial internet campus. So we have quite a realistic industrial simulated environment. So we have the overhead crane, and we also have like mobile robot and the research elevator. So it simulates the whole material flow. And then we use the environment 5G network for the communication. And the persona here is a crane operator, or so it can be, the persona can be on site. So on the I think right bottom side, you can see these on-site operation scenarios. So use the virtual controllers, have had additional information augmented. And then also on top, you can see the VR use case, which is the operators can be remotely in some other locations and have either virtual training version or like have really data connection with a real crane and have the remote control. They're also like supporting multi-user experience. So I think for crane control is rather simple, but we had another case of the elevator inspection. So there, it's like remote collaboration. One technician is on site in the elevator and another more expert level like inspectors in remote collaboration locations, so they can do this real time with 360 videos and VR AR headsets on the on-site technicians. So yeah, so some use case like apply the proposed architecture. Yeah, so come from technical side or practical side. Now we look into also something that we shouldn't avoid because, yeah, it's on the ethical side implications of metaverse, especially applying workplace. So motivation of this research is that, like, I'm more from engineering, so I always, in the previous talks, I only talk about the technical part, and I always get this question in a Q&A session. So I would say, I decided to collaborate with someone from ethical background as well, ethical researchers from Cambridge. So we did some exploration in this field, so I can hopefully answer the question if someone asks me in Q&A. So yeah. So here we did first like a systematic literature review on like existing like public cases and also like research works addressing the ethical implications. And we summarize these 8 themes. Some of overlapping with the previous like more business survey results. So privacy, data security is a big concern, but also like in the workspace, like employee monitoring, surveillance is a big topic as well. Then we also have inclusion and accessibility, especially considering like people might have cybersecurity, cyber sickness, like this motion sickness symptoms in virtual environment, and also like the current extra system didn't adapt to all kind of user need. And then also the physical and mental health risks. So it's always double like bladed sword. So in the way that also the fully immersive VR environment and remote working setup can also distance people and workers in the team. Then we also have label datafication or employee autonomy risks. So these are more like kind of, as workers, you are kind of shrink to a data point. So that affects the autonomy as a kind of basic human right. Then we also have bias and discrimination. So these more come from especially use AI algorithms in the data side and also the modeling side. So how do you really model different diversity of the users? Then they also like call for need of ethical standards and also transparency because there's currently uncertainty in especially the regulation side. Of course, the safety of shared content, it's a big issue, I think, in consumer metaverse, but of course, in workplace as well, it applies. Then I also have an exploration side project I collaborate with legal researchers in the field. So we analyze how existing EU legal standards apply to metaverse, and we focus on this 6 gray box on the bottom, these 6 fundamental rights. So privacy, data protection, equity, equality and no discrimination, digital identity, human autonomy and self-determination, then also the freedom of expression and information simulation in the virtual environment, fair and just work conditions. So this more concerning the workplace applications, and also the physical and mental integrities, especially consider yourself and this embodied approach with your avatars, for example. Then we identified 4 legal standard that can apply to Metaverse, related to Metaverse, so GDPR, of course, but also the Charter of Fundamental Rights of EU and the Digital Service Act, because Metaverse is considered as these very large online platforms. Then also EU AI Act, considering now how much integrated AI and Metaverse are. Yeah. Then I also have a recent paper. This is in ESMA workshop, like biggest XR or AR techno conference. And here I basically considering address XR evaluation. So the paper is called Are we measuring what matters? Because of course, like if you are doing like HCI related research, there's like a very standard way to do the evaluation, which is like for example using NASA TLX and SUS and floor level, this kind of test to measure if the system is effective, and maybe for industrial works like completion time, error rate, so this kind of standard. But then if we really consider a bigger picture and question it more from fundamental level, is it the technology bring values? Then and that's a framework I proposed. So first, technology fit. So really, is the task does the task need extra technologies? Does it bring values? Then also the 3 dimensions of Industry 5.0 principles. So human centricity, sustainability, and resilience. So here I listed sub-dimensions for measurement and also the code metrics with reference. So if you're interested, feel free to check the papers in detail.
Dr. Tu, I don't want to push you up the stage, but yeah. I'm tasked with keeping going. You have so much wonderful information here. I know it's hard to pack it in, but we have...
Almost done.
Okay, great.
Yes.
Thank you.
Yeah, maybe I talk too much, but yeah, I have so many interesting things to share. Yeah, here's, I think, second last slide. So here is like an overview of the project we have working on. So these are all like industrial academic collaboration projects funded by Business Finland. So a lot of exciting things going on, from digital twins to Metaverse to the data economy and operating models to integrate IT and OT models. And here is the final takeaways. Yeah, Industry 5.0, Industrial Metaverse, and the architecture, ethical, and legal aspect. Thank you.
Thank you so much. That was wonderful.